Howdy, y'all. No, I'm not going to use that accent through the whole thing, but I just like saying howdy, y'all. Today we're going to be looking at asymptotes and using limits to find them, and then discussing the behavior of the graph as you get close to those asymptotes. Now, by asymptotes, we're talking about both vertical and horizontal. So let's start with the vertical because we're already more familiar with those. You may remember to find vertical asymptotes, we set the bottom equal to 0. Now, that's a half-truth because when we set the bottom equal to 0, what we're really finding are not asymptotes, but discontinuities. Okay, so here we're finding discontinuities because there's also the discontinuities that are removable, the holes. So what we're going to do is we'll go ahead and factor. So we go 2x squared minus 1. So this factors 2x plus 1, x minus 1. And so therefore x equals 1 and negative 1. So at both of those you have a discontinuity. Now we actually have to go check the top because the top is going to tell us if these discontinuities are holes or if they're vertical. So what we're going to do is we're going to set the top equal to 0. And so we're going to go negative 1 plus 2x minus x squared. Now when I'm factoring that, I'm going to take the negative out, which means I'll have a positive x squared, a minus 2x, and then a plus 1. Okay, now from here I'll take the negative, I'll factor that, which will go to x minus 1, x minus 1. Alright, and so therefore x equals 1. Now what that means is that one of these x minus 1s would feasibly cancel out right there. Okay, so what that means is that then is a removable discontinuity, that's a position where there's not a vertical asymptote. Alright, there's something else going on there. Okay, so what we're going to do is we're going to go ahead and draw our number line. Now remember on this number line for our sign diagram, what we're going to include is our vertical asymptote, which there's a vertical asymptote at x equals negative 1 because that one didn't cancel out. So at negative 1 I'm going to have this dashed line. And then I've got at x equals 1, that should be then a discontinuity. So I'm going to put a hole there at positive 1. Alright, so from there we'll go ahead and consider the horizontal asymptote. Now for the horizontal asymptote, what we're going to do is we're going to find the limit as x approaches infinity. Because the horizontal asymptote is what do we get closer to as we go farther and farther out here. And so we'll go negative 1 plus 2x minus x squared over 2x squared minus 2. And so the easiest way to do this, because of the infinity, dividing infinities by infinity is kind of crazy and messy and we can't really deal with it. So what we're going to do is we're going to divide everything by the highest degree variable. And so everything will be divided by x squared. So I'll have negative 1 over x squared plus 2x over x squared minus x squared over x squared all over 2x squared over x squared. Now since I'm doing it to everything, then it's okay because I'm doing it to the top, I'm doing it to the bottom, I'm doing it to every piece of the top and the bottom, and I still need the limit as x, I haven't done the limit yet, as x approaches infinity. So now I'm actually going to do the limit. Now as x gets close to infinity, then 1 divided by that infinity is going to be 0. So that's going to be 0. Now here, a similar idea, you've got infinity over infinity, but notice that this infinity down here, it's infinity times infinity. Any number you take and divide it by infinity times infinity, even if it's getting closer to infinity, I know that's weird to think of, you could, if it makes it easy, you can cancel out one of those x's, leaving you with just an infinity, which means you're still going to have 2 over infinity, which is going to be 0. Now here, the x squareds actually cancel out, leaving you with minus 1. On the bottom, here, the x squareds cancel out, leaving you with 2. And then here, minus 2 over infinity squared, because x is getting closer and closer to infinity, again will be 0. So when we work this out, we'll end up with negative 1/2. And so this is our horizontal asymptote, is when y equals negative 1/2. Now IB will usually ask for an equation, so make sure you put the y equals negative 1/2 on there. Okay, so we could kind of draw that in. That's not really part of your sign diagram, so if this is supposed to be a sign diagram, then don't draw this on here, but it might be helpful as we're starting to kind of look at things and try to figure out what's going on. Okay, so we found the asymptotes. We found a vertical asymptote at x equals -1 and the horizontal at y equals -1/2. So now what we want to do is discuss the behavior. So we're discussing the behavior as we get close to those asymptotes. So what we're going to do is we're going to start out here to the left. Okay, actually let's put in the signs for our sign diagram first. Okay, so let's just choose a number. Let's say 0. Okay, and if I put 0 in, then I got 0, 0, so it'll be -1 over -2, which will be positive. Okay, what happens if I put a really big number in here? Well, if I've got like 1,000 or something, then I'm going to have a really big negative number there divided by a positive number, so I'm going to get a negative. And then over here, I'm going to have, let's see, if I put a really big negative number in, I should get essentially the same thing. I'll have a negative or a positive. If you're not sure about this, then just take a number, put it in. You know, try putting 2 in and work it out and see what you get. You'll find you get a negative number. Try putting -2 in or -10 in. When you work it out, you'll find you get a negative number. Okay, now this is a little bit confusing, possibly, because we said before if there's a double intercept, then it should alternate. But remember, you actually have a double intercept and a hole here, which means there's more going on than what we expect, and that's why you end up getting something like this. So we continue with this idea, and we now say, okay, well, let's discuss the asymptotes. Well, being that it's negative here and has an asymptote there, then chances are my graph looks something like this, because it's got to go to the asymptote. It can't go up because then it would have an x-intercept here. So my graph probably looks something like this, which means, and with the in behavior we always say as x approaches. Well, as x approaches this direction, that means as x is going way down to -infinity, y approaches. Now what's y getting close to? Well, it's getting close to that horizontal asymptote, which is -1/2. But not only is it -1/2, it's approaching -1/2 from the bottom. And so we put a little minus there to show that it's approaching from the bottom. Okay, then we say as x approaches, what's the next asymptote that it approaches? Well, it approaches -1. And as x approaches -1, y approaches. Well, what's happening to y as we get closer and closer to -1? Well, it's going down to -infinity. Okay, now that's approaching -1 from the left. Now we should also, because asymptotes don't have to go alternating, but in this, why does that keep coming up? So we're going to now approach -1 from the right. So as we approach -1 from the right, we're going this way. Now notice that it's positive here. That means it can't have crossed the x-intercept, x-axis, so it can't be coming down here and jumping up, because that would have, again, an x-intercept. So it's got to be up here, going something like this. There's your hole, and then after the hole, it crosses down, approaching the asymptote. And so we can say as x approaches -1 from the right, that's the plus, that means that y is approaching +infinity, because it's going up to infinity there. Alright, so we've approached -infinity, we approached -1 from the left, -1 from the right. The only one we have left is this one out here. So as x approaches +infinity, y approaches, and so as x approaches +infinity, y approaches -1/2 again, but this time note that it's approaching 1/2 from the top, and so we'll say x approaches -1/2 from the top, just like that. Okay, so for y, plus means the top, minus means the bottom. For x, plus means the right, minus means the left, just like you would expect for x going side to side and y going up and down. All right, let's go ahead and look at one more, just because I got one more. We'll go through this one a little bit quicker now that we've got the idea. Okay, so first we'll find the discontinuities. So we'll go x squared plus 1 equals 0. We'll subtract 1 from each side. X squared equals -1. Oh, we can't take the square root of both sides. Well, we can, but it would give us an imaginary number. So there are no vertical asymptotes. Okay, so we've got that. Let's get the x-intercepts, because we need the x-intercepts to be able to get the sign diagram. So to get the x-intercepts, we make the top 0, so x squared minus 1 equals 0. You could factor this, you could add 1, however you want to do it. Just remember, if you square root, then x will be plus or minus 1. And so when I draw my number line, I need a -1 and a +1. Just like that. These are solid because they are x-intercepts. There's no holes there, right? There were no discontinuities, so there's no holes, no vertical asymptotes, so solid lines. Next, we wanted the horizontal asymptote. So to get the horizontal asymptote, we look at the limit as x approaches infinity. You could do negative infinity if you want, but why make life difficult? So we find it for the function, and so then we divide by the highest degree. So we say the limit as x approaches infinity of x squared over x squared minus 1 over x squared over x squared over x squared plus 1 over x squared. And again, this will become, those cancel out, leaving us with 1. The limit as x approaches infinity of 1 is still 1 because x doesn't affect 1. It doesn't matter if x is going to infinity because 1 is just 1. And then here, as x goes to infinity, you get 0. Again, those cancel out, leaving you with 1. So we get 1 plus 0, which means that the limit, we took the limit, therefore the limit's gone. When you divide these, you get 1. So our horizontal asymptote is at y equals 1. And like I said before, you should write that as an equation. So at y equals 1, again, this is not part of your sign diagram, but you may find it helpful as you're trying to talk about in behavior. Okay, now we check our sign diagram. We put some values in here. I don't know, maybe if we put 0 in, we'll have 0 minus 1 and 0 plus 1, which means you'll have a negative on top and a positive on the bottom. And when you take those, you divide them, you get a negative number. Now this one, since there's nothing weird happening, then we can expect that it'll go positive there and positive here, which then means that it will continue on. Plus, minus, plus. If you're not sure, you can go ahead and plug in numbers. You put 10 in, you're going to get a positive number. You put negative 10 in, you'll get a positive number. Okay, so now let's talk about the graph near the asymptotes. Okay, so there aren't any vertical asymptotes, so we don't have to worry about that. But anyway, the first one we look at is as x approaches. Let's look to the left. So as x approaches negative infinity, y approaches, well, it's positive here, negative, and then positive again. So we expect the graph to look something like this. Positive, negative, there's no asymptotes, and then positive again, approaching the asymptote. Now, it's possible that it crosses or something like that. We'll learn a little bit more about that later, but for now, we're not going to concern ourselves too much with that, other than just recognizing this idea that it's probably then approaching from the bottom. So y approaches our horizontal asymptote from the bottom. And then we're going to skip up to as x approaches infinity because there's no vertical asymptotes here. And so that means y approaches 1 again from the bottom. And so we'll label it as approaching from the bottom. Okay, so there we go. We've gone through 2 examples of determining asymptotes and discussing the end behavior, essentially what we're doing here, talking about the ends of the graph, both horizontally and vertically, as we looked at in the previous question when we were looking at the vertical asymptotes. Keep in mind the signs should alternate. If there's a hole, then technically it cancels out, which is why then this will continue to alternate from plus to minus, because there's really only one root there. The second one doesn't count because it's a hole, it's not actually an intercept. A hole will never cause a double root. It just continues on alternating just like it should, just like an asymptote. Discontinuities don't affect that. Okay, so hopefully that was helpful, and if you have any other questions, please let me know.